Hello, ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. We are now doing section 5.2, which is using intercepts. Last time we learned what a linear function was, and today we are going to learn how to use intercepts for finding and graphing a linear function. But before we can use intercepts, we have to know what the heck they are, so we're going to start with the Y-intercept. The Y-intercept is the location, or the y-coordinate. I'm going to say the location. The location where a graph crosses the y-axis. So the location where a graph crosses the y-axis. So if we were looking at this function over here, where it comes up and over, its y-intercept would be right there. That would be its y-intercept, or y-int. It's where you cross the y-axis. Now, a cool thing about the y-intercept that you should probably know is the y-intercept always occurs when x is equal to 0. So you know this is an x and y graph, where the x graph, or the x-axis, is the horizontal axis and the y-axis is the vertical axis. So when we're looking at it and it says the location where the graph crosses the y-axis, it will always occur when our x is 0, because that's the location of our y-axis. Now let's move on to the next thing. The next thing would be, of course, the x-intercept, because we only have x-intercepts and y-intercepts at this time. So the x-intercept would be the location where a graph, and hopefully you figured it out by now, that's right, where a graph crosses the x-axis. So looking at the similar graph that we just drew, if we're looking at this particular one, that's a bad one, sorry. That's worse. That's still bad. Ha! There we go. It would be the location where we cross our x-axis, which would be right there. That would be our x-intercept, or the x-int. So a cool hint about the x-intercept, and I think you've probably figured it out by now, it always crosses when y is equal to 0. Again, we still have that x, y thing going on with our Cartesian coordinate system. So yes, the x-intercept will be when we cross the x-axis, the y-intercept will be when we cross the y-axis, and if we go into 3D and 4D and 5D graphing, the z-intercept would be the crossing of the z-axis, and the v-intercept would be crossing the v-axis, and so forth and so on. The I-intercept would be crossing the I-axis, etc., etc. Alright, so let's go ahead and see if we can figure out from a graph what the x and y-intercept are. So let's go graph. If we were in Mighty Morphin Power Rangers universe, we would say it's graphing time. So here's our first example. Let's say that we have a beautiful graph. Pretend it's beautiful. Thank you. And on this beautiful graph, we have a spot here, and we have a spot down here. And our graph goes between those two spots. Then we would say that we have an x-intercept at what location? Would it be here or here? Well, if you said the first one, you are correct. And if we wanted to, we would have to find its coordinate location. From the looks of it, it's 1, 2, 3, 4 to the left. So that would be -4. And because it's the x-intercept, my y value will always be 0. Now, what about the y-intercept? Same thing, right? Except we're going down. Here's our y-intercept. Here's our x-intercept. Our y-intercept is at 0 because the x-coordinate of our y-intercept will always be 0. And then -4. Note that they are in an ordered pair. You don't have x_int equals 2. You can do this, but it's kind of frowned upon, mainly because coordinates are way better. So sometimes we will be using x_int equals 2. Sometimes we will say x-intercept is equal to -4, 0. Both of them are correct formats. However, I prefer these because they are less confusing. You know exactly where it is. Whereas on these, it's like 2. Okay, is that to the left or to the right or up or down or what? What's that 2 mean? Is it a radius of 2 in a circle? A little bit ambiguous, just to have a little number out there, but when you have an ordered pair, there is no ambiguity. So let's look at another one. And on this one, let's say that we're given a formula or an equation, and we are asked to find the x and the y-intercept from the formula. Let's say that we are given 3x minus 2y is equal to 12. And we are told to find the x and y intercepts. So this is where that cool key thing that I said earlier comes into play, where the x-intercept always occurs when y is 0, and the y-intercept always occurs when the x is 0. So we're going to break this into 2 sections. One's going to be x, the other is going to be y. And for the x, to find the x-intercept, set y equal to 0. Set y equal to 0 and solve. So we have 3x minus 2y, which just got set equal to 0, is equal to 12. Doing some fancy arithmetic, we get -2 times 0, which is 0. So we have 3x is equal to 12. We divide both sides by 3, and we get x is equal to 4. So the x-intercept would be at 4. But if we were going to be really good, we would say that it would be at the location 4, 0 for our x-intercept. This would be the better format. Would this be accepted? Yes. Is this better? Yes. It's kind of like, can you have plain vanilla ice cream? Yes. But if you put Hershey's chocolate syrup or fudge on it, isn't it better? All right, now looking at the y, remember to find the y-intercept, you set x equal to 0 and solve. So we have 3 times our newly set to 0 x is subtracted by 2y and is set equal to 12. Doing some really fancy arithmetic, 3 times 0 is 0. We now have -2y is equal to 12. Divide both sides by -2, we get y is equal to -6. So our y-intercept would be at 0, -6. Gotta love that chocolate syrup on top. Pretty easy stuff? Yeah, I thought so. So let's look at another situation where I want you to both find the x-intercept, the y-intercept, and then graph. And we're going to be using standard form for this one. So this is a good lesson in how to graph in standard form. I like to call this the Nixon method. But some other people like to call it the cover-up method. And if you don't know why it's called the Nixon method, please go study some US history. It is an interesting event. So for the Nixon method, let's say that we are told to graph f of x, oh sorry, I can't use that method. Graph 2x plus 4y is equal to 8. Now to graph this guy, we start with the Nixon method, which is to cover up. Basically what we're going to do is find the x and y intercepts and then draw a line between them. Alright, so first we get to do our x portion and our y portion. Now we could do it the same way that we've been doing it before, where we plug in for the x portion, plug in 0 for y, and then solve for x. And we could do it using the same thing for the y. You would have 2 times 0 is equal to, plus 4y is equal to 8. 4y is equal to 8. Y is equal to 2. And you would be good to go. But that isn't really a cover-up, is it? So here's the cover-up method. A way to do this more quickly without having to do so much work. To find the x-intercept, you cover up your y. You have 2x is equal to 8. Divide both sides by 2, you get x is equal to 4. Oops, I didn't want to do it that way. Here we go. So using the cover-up method, we still get the same location. Now, what about for the y? Well, for the y, you cover up the x. You get 4y is equal to 8, so y is equal to 2. Doing this method allows you to do enough arithmetic in your head to find the x and the y intercepts without really having to show much work. So then, we come to our graph. We know that our x-intercept occurs at positive 4. So we go to positive 4. 1, 2, 3, 4, and make a dot. We know that y is equal to 2, so we go up 1, 2, and make a dot. So this is at the y-coordinate, or the y-intercept of 0, 2, and the x-coordinate of 4, 0. We then draw a line between our 2 points, and shazam, we have our graph. All done. Much easier with the cover-up method. Now I know what you're thinking. Mr. O'Neill, I've only seen this once. There's no way I can do this on my own. So let's see it again. Let's go with another example. Oh yeah, you probably want to copy this down for a little longer. So while you're copying that down, I will write down our new one that we're going to graph. Our new one is going to be 3x plus 4y is equal to 24. Here we go. Step 1, draw my axes. Step 2, I'm going to find the y-axis or y-intercept first, so I'm going to cover up my x. So we get, let's see, 24 divided by 4 is 6. That's a little bit too big for this graph, so I'm going to go by halves. So that'd be 1, 2, 3, 4, 5, 6. Make a dot. And then on the other side, we cover up our y, and we get 3x is equal to 24, which gives us an x-intercept of 8. Now remember, we're going by 2, so 1, 2, 3, 4, 5, 6, 7, 8. Make a dot. Connect the dots. And call it a graph. That was a little bit of humor there, so. You guys are such a tough audience. All right, moving on. We know how to graph in standard form using the cover-up method. We know how to find the x and the y-intercept. We know what the x and the y-intercept are. That's everything that we need to know for today's homework. So today's homework, as I hear you guys scrambling around, probably standing up to get your books, even though I haven't even written it down yet. I love teenagers. Here's your homework. This is going to be section 5.2, hashtags. One through 11 odd. 15, 17, 21, 23, 25, 27, 31, 33, and 34 through 37, all. Sorry, all. Since they kind of go together. And I think that'll be all of it. So there's your homework assignment. Go ahead and remember to stay in your seat. There is no reason to get up other than maybe get your book. Once you have gotten your book, sit back down, stay in your seat, ask if you can leave your seat. But otherwise, good luck and have fun.